supervised learning. By the end of this lesson, you will be able to list the different types of supervised learning, describe various regression algorithms, explain advanced regularization techniques, describe logistic regression and accuracy matrix, build various regression models. Supervised learning. Supervised learning is a type of machine learning used to train models from labeled training data. It allows you to predict output for future or unseen data. So what is labeled data? Labeled data is a group of samples or features that are tagged with one or more labels. Training data needs to be fed to a machine learning algorithm in order for it to generate a machine learning model that learns from your algorithm. The learning algorithm discovers patterns in the training data such that the input parameters correspond to the target. The output of the training process is a machine learning model which you can then use to make predictions. This process is also called learning. Let's understand supervised learning by looking at some examples. Consider the weather app. It makes predictions based on prior knowledge and analysis of weather over a period of time for a particular place. Weather forecasts are created by assembling as much data as possible concerning the present state of the atmosphere, particularly the temperature, humidity, and wind, and understanding of atmospheric process through meteorology to determine how the atmosphere will evolve in the future. Supervised learning can be used in this case as all data is labeled data. Let's look at another example. We use Gmail filters every day. Gmail filters are used to decide whether a new email has to fall into the inbox, normal, or junk folder spam based on past information of spam. Whenever a new email comes in, Gmail checks for spam based on the sender's email, IP address, and email content. If Gmail finds any of these misleading, it flags the email as spam. It also collects further reactions of the email receiver. Has the user marked an email in the spam folder as not spam or opened the mail? Similarly, if an email is marked as not spam, does the user mark it as spam or delete the email immediately, or does the receiver block the sender? Supervised learning can be used in this case as all the data is labeled data. Supervised learning real-life scenario. Have you ever wondered how Netflix makes recommendations? When you first sign up, it asks you to choose the 3 shows you like, and based on that, it predicts more shows that you like. Let's understand how it uses supervised learning to do that. Netflix uses supervised learning algorithms to recommend shows to you based on the genre. Supervised learning reasons by similar classes of users. Similar classes of users are those who selected the same shows you did when they first signed up. When a new user finishes signing up, the user is given recommendations by algorithms trained on historical data. Historical data can be the most watched shows by new users in the past, most searched shows by a new user in the past, or other relevant information. Understanding the algorithm. Now let's understand the algorithm behind the learning model. The training data consists of inputs, also known as features, and output, also known as labels. For example, the color, size, and weight are the features of a fruit, and the name will be its label. Consider the given training data. X column is the input and Y column is the output. Train the algorithm by applying reverse engineering by looking at the relationship between X and Y. What is the relationship that has been defined here? Y equals F times the set of X, where Y is some function of X. This is also called as learned algorithm. Using the learned algorithm, predict Y values for the new instance using Y equals F times the set of X. Supervised learning flow. Let's understand the flow of supervised learning. There are two steps involved in building a supervised learning algorithm. The first step is training and testing. The second step is prediction based on training and testing. Let's understand the training and testing phase. Once you have gathered all the historical data, you need to do the random sampling of the gathered data. This will give you the train and test data set, which is divided in the ratio of 70 to 30. What is random sampling? In random sampling, the total population data is randomly distributed between different samples, where each sample has an equal probability of being chosen. A sample chosen randomly is meant to represent the total population. If the sample does not represent the total population, apply machine learning algorithm on the trained data set, that is 70% of the sample data, and use statistical modeling. You will get the predicted value as the result of it. The test data set, the remaining 30%, is used to validate the predicted outcome and come up with the model validation outcome. Now, when you have tested the data, you may want to use to make predictions and gain insights. So, let us understand prediction. Once you get the model validated outcome from the training and testing phase, use that as a new data for prediction. Apply statistical modeling and use the learned algorithm y equals f times the set of x to make predictions. You will get the prediction outcome as the output from the statistical model. Algorithm prediction can be improved by more training data, capacity, or algorithm design. Types of supervised learning. Part A. There are two types of supervised learning: classification and regression. Classification is a supervised learning type where the output has predefined labels that have discrete values. A discrete value is a value that is obtained by counting. The goal of using classification is to predict discrete values belonging to a particular class and evaluating on the basis of accuracy. Regression is a supervised learning type where output is a continuous value. A continuous value is a value not restricted to defined separate values, but can occupy any value over a continuous range. The use of regression is to predict a value as close to the actual output value as our model can, and then evaluating it by calculating error value. The error value is inversely proportional to the accuracy of our regression model. The smaller the error value, the greater the accuracy to the regression model. In supervised learning, the algorithm is selected based on the target variable. When can you use clarification? You use clarification when the target variable is categorical. In other words, classification is applied when the output has finite and discrete values. Let's understand it by using an example. Suppose you want to predict the class or category of a car when you have its feature details with you, like horsepower, mileage, weight, color, etc. The classifier will build its attributes based on these features, and the analysis has three potential outcomes: sedan, SUV, and hatchback. So here in this example, you have all the categorical data with you, and thus it becomes easy to predict outcome using classification. Types of supervised learning. Part B. Let's try to understand